right, so last section we're going to look at is the second half of 6.2. Okay, so really, two things we're going to do in this section. Okay, first thing we're going to do, we're going to work with unit circle trig again. Except instead of just finding the sine, the cosine, and so on for the quadrantal angles, we're going to do it for any angle that's a multiple of 30 or 45. All right, so pi over 6, that's 30. Pi over 4 is 45. Pi over 3 is 60. But if something's a multiple of 30, it's automatically a multiple of 60. All right, so by me saying we're going to do all the multiples of 30 and 45, that also covers multiples of 60. All right. And the last thing we're going to do is look at trig identities. Okay, trig identities is something we're going to kind of look at a little bit today, not much. Eventually, we're going to spend a whole week on this one topic. Okay, so on the test, I think there's just one question with trig identities, because this topic can be pretty involved. Okay, so we're not going to do much with it today.
What did you say those were?
This is 30. This is 60. This is 45.
No, how do you do that to show that?
Okay, if I wanted to convert pi over 6 to degrees by hand, how would I do it? Multiply by 180 divided by pi. Pi's cancel. What's 180 divided by 6? 30. Okay, so when we are dealing with radians, it is helpful if you can memorize the quadrantal angles. Okay, you should know those. And these three, 30, 60s, and 45s. Anything other than these, like if you had something like 7 pi over 13, I don't know what that is in degrees. I mean, I could find out. But this is a strange angle. All right, so if it's not a multiple of 30 or 45, I wouldn't expect you to have it memorized. Okay. All right, so let's take a look at the diagram I have up above. Okay, so first thing I have drawn is a circle. Okay, here's 0. Here's 90. Okay, this time what I've drawn is I marked 45 degrees. And I drew a ray to make my angle from the center right to 45 degrees. Right, and my goal here is to find the 6 trig functions for 45. But in order to do that, I have to know the coordinates for 45 degrees. Okay, and right now, I don't know them. You've seen them, but I didn't tell you that this is what they were. Okay, so now we're going to find out what they are, and once we know them, we never have to find them by hand again. So once we find them, we're going to write them down, and we're going to memorize them. Yeah?
Is it just pi over 4?
Well, that's in radians, but remember, I want to know an x and a y value.
So we just have to convert.
Yeah, we're going to convert this angle to a coordinate. Okay, that's the goal. Now, what shape do you think I could make out of this? Yeah, we're going to make a triangle out of it. Okay, now, we're not converting degrees to radians here. I want to make that clear. We're not trying to find a different way to write this angle. We're trying to write this angle as a coordinate. How far to the right do I go? And then how far up do I go? Okay, pretend that this was on graph paper. I want to give me directions from the origin. How far right and how far up to get to this angle. Okay, so now this is a 45. That's a 90. So what's this other angle up at the top? Yeah, all the angles have to add to 180. So I have the same triangle, just a little bigger down here, so we can work with it easier. Yeah?
So like inside the unit circle?
Yep, that's what this is. This is a unit circle.
45-degree angle, like basically creates a box because it's 1. So that, like, come on, make it up. Quick.
All right, so what our goal is, we're going to try to figure out what the coordinate is for 45 degrees. Now, what kind of triangle is this, besides being a right triangle? It's what? Yeah, it's isosceles. And what does it mean if a triangle is isosceles?
sides are equal.
Two sides are equal. Okay, so I don't know what the height is. Okay? I don't know what the base is, but I know that they're the same. Okay, so whatever the height is, the base is the same. Okay, so we don't know either one of them. So when we don't know something, we represent it with a letter. Okay, yeah, let's just use x for the base. What does that mean I'm going to use for the height? Well, I'd use y if they're different, but they're the same. So I'm going to use x again. And now the hypotenuse here, I already know. Okay. This hypotenuse, go back to looking at the circle, is really the what of the circle? It's the radius. Okay. And since we're on a unit circle, how big is my radius? It's 1 unit. Right. Now all I have to do is figure out x. Okay, it's a formula you've probably used before. I don't know if we've used it in here yet. But what theorem can I use to find x? Yeah, the Pythagorean theorem. Okay. The Pythagorean theorem says if you take one side and square it, plus the other side squared, it equals what? 1 squared, the hypotenuse squared. Right? So now we're just going to solve and see what we get for x. Okay, x squared plus x squared. How many x squareds is that?
4.
Well, I have 1 here, 1 here, which is 2. Okay, so we get 2x squareds. 1 squared is just 1. Okay, what can I do next to get x squared by itself? Divide by 2. So I get x squared equals a half. But now I want to get rid of that exponent of 2. Take the square root. When you take the square root of a fraction, you do it just like that. You do the top and the bottom separate. Okay, so square root and square cancels out. And what's the square root of 1? 1. Square root of 2, I can't really do anything with it. But how do I fix that? That's never how we should leave an answer. Multiply by the square root of 2 over the square root of 2. So in the top, that gives me 1 times the square root of 2, which is, and in the bottom, we talked about that, the square roots cancel. We get 2. Okay, so now we know what x is. We know how long the bottom side is, and we know how tall the triangle is. Okay, so let's go back up. What is the length of the bottom side? Which was x. Square root of 2 over 2. Okay. What was the height of this triangle? Same thing. So the coordinates to get to 45 degrees, you need to go right, how much? Square root 2 over 2. And then you need to go up, how much? Square root of 2 over 2. So that's the coordinates for 45 degrees, and that never changes. So anytime we've got a 45-degree angle, we're always going to use those coordinates, and we're going to memorize it so we don't have to go back through and do that again.
Those exact coordinates?
Yep. Anytime you draw a 45-degree angle on the unit circle, that's always the coordinate. Just like the coordinate for 90 is always 0, 1. That never changes. Okay. That never changes. Okay, so now we know the 45-degree angle. Any questions on that one? Right, so before we do an example with it, let's get the coordinate for the 30 and the 60, so then we can just do all the examples together. Right, so there's 2 coordinates we have to find, the 30 and the 60. But once we get the 30, I think you'll see the 60 is very, very similar. Okay, so I have both triangles drawn on here at the same time. This is 0, that's 30, that's 60. What's the one at the top? 90. Okay, and what I'm going to do is I'm just going to work with the lower triangle first. Okay, forget about the one that's standing taller. Okay, I'm going to work with the one where the 30 is at the bottom and the 60 is inside at the top. Okay, this other triangle, I'll put it in red. We're not working with that one right now. Okay, we're working with the one at the bottom. And I'm going to draw it larger over here so it's easier to write stuff down.
Aren't those two triangles the same size?
Yes, they're the same triangle, just kind of flipped and turned on its side. Yep. But yes, these are congruent triangles. The one in red and the one in black. So that gives you a real hint. If you know the coordinates for 30, it's probably pretty easy to get the coordinates for 60. Just, we'll see. All right, so this time we can't do the same trick we did last time, okay? Because all of these angles are different. This is not an isosceles triangle. Okay, but there is one side I still know. How long is the hypotenuse? Yeah, it's 1. Okay, because that's still the radius in the unit circle. Unfortunately, 1 is not part of the coordinate. I need the bottom side, and I need the height. All right, so this is a little bit of a trick to figure out how we do this. Okay, I'm going to take this triangle, group everything. I'm going to make a copy of it. Paste it. And I'm going to flip it. I'm going to flip it like this. Now, by flipping it, did I change any of the sizes of anything? No. I just made like a mirror image. Okay. And I'm going to put it right here. Now, I'm only going to need this mirror image temporarily to figure something out, and then I can get rid of it. Okay. I want you to look at what kind of triangle I just created. The big, right? This is 60. This is 60, and that's 60. So if this side is 1, how long is this side? 1. And how long is this big side on the right? 1. Now, this big side on the right is made up of 2 smaller sides that are equal in length. What are 2 numbers that are equal that you can add together to get 1? 0.5 or a half. So that proves this side is a half, this side is a half. So my only reason for doing that was to figure out that this top side was 1/2. Okay? Now I don't need the bottom triangle anymore. Okay? And in fact, I'm going to get rid of it. I'm just going to move it so it doesn't mess us up. Okay, so any questions on that? Now, how many sides am I missing in this triangle? Just 1. Pick a letter. Now, we don't have to pick a letter for this other side because we know the number for it. It's a half. And how could I find x?
X squared plus half squared.
X squared plus a half squared
Plus 1 squared.
equals 1 squared. Yep. And now we just do out the Pythagorean theorem one more time, and then we'll have x. So we get x squared. What's half of a half?
1/4.
1/4. Next thing I need to do is bring my 1/4 to the other side. What's 1 take away a quarter? 3/4. And last step to get x by itself. Take the square root. Can I simplify square root of 3? No. Can I simplify square root of 4?
Yeah.
Yep. 2. Great. So now I know this side is square root 3 over 2. All right, so let's go back and look at our triangle. In the 30, 60, 90, this side I just drew in green, how long is the bottom side? So look at our diagram. Square root 3 over 2. How tall is the height? 1/2. So what are my coordinates to get to 30 degrees? Yep, square root 3 over 2, 1/2. Now, we don't have to go through and do that whole thing all over again for the red triangle. It's the same triangle, just standing upright. So now the short side is on the bottom. Okay, if I draw that, and the tall side is the height. So what do you think your coordinates are for 60?
4.5
And square root of 3 over 2. Yes. Okay, if you were to write these as decimals, 1/2 is what decimal? 0.5. Square root 3 over 2 is about 0.86. It's a little bigger. Okay? So the way I want you to remember it, the short side is always the small number. Short side is the small number. The long side is the bigger number. Okay? And if we memorize those two coordinates, that's all we need to do everything we're going to do with unit circle trig. Those two coordinates, that coordinate, and make sure you know the 0, 90, 180, 270. We did those yesterday. Okay, those are the easy coordinates. Okay, the 0, 90, 180, 270, you're never going to have square roots with those. You just have ones, negative ones, and zeros. Okay? All the other ones, the 30s, 45, and 60, you got square roots. All right. So the next 4 or 5 problems, we're just going to try finding trig functions. For some of them, we'll do all 6. Okay, eventually, I'm going to stop doing all 6. We'll just do like a few because it gets pretty repetitive. All right. So the first thing they said is find 6 trig functions of 45 degrees. Before you can even start the problem, what do you have to know? You've got to have the coordinate. You've got to know the location for 45 degrees. So, yep, either you memorize it, or if you're not sure, draw your circle, make a sketch, and maybe the sketch will refresh your memory. Okay. So what's our coordinates for 45 degrees? Comma, square root 2 over 2. Does that coordinate look familiar?
Yeah, we did it.
It was in the homework last night. Okay? I didn't tell you it was a 45-degree angle. You didn't need to know that. Okay? All I asked you was to find the 6 trig functions. We've already done this problem. But we can go through it again real quick. Okay, what's my sine? Square root of 2 over 2. How about my cosine? Also square root 2 over 2. And what about my tangent? 1. Okay, my cosecant. Does anybody remember what you get when you flip it and we fix it?
2.
Just square root 2, right?
Just square root of 2. Okay, we went through that on the homework. How about my secant of 45? Same thing. Okay, we're flipping the same thing again. And my cotangent? 1. Okay, anytime you flip 1, think of it as 1 over 1. It's 1 over 1 when you flip it. Questions on that? Okay. Right, let's try the 6 trig functions of 30. Okay, 30 and 60 are ones that can be a little tricky because you got to remember which one is the 1/2 and which one is root 3 over 2. Okay, so if you don't remember that, make a sketch. Try to make it somewhat accurate. 30 is closer to 0. Where's my long side in this triangle? Is it the base or is it the height? It's the base. And what's the bigger number? Since that's the bigger side between root 3 over 2 and 1/2. Root 3 over 2 is the bigger number. My height, that's the shorter side. What's the smaller number? The 0.5, or the 1/2. So now this tells me my x is root 3 over 2. My y, my height, is a 1/2. Okay, so just write your coordinate somewhere. And now we go through all 6. Okay, Matt, what's my sine? Yep, sine is my y. Good. Taryn, what's my cosine?
Cosine is
square root of 3 over 2. And now my tangent, I'm going to divide y by x. Just imagine putting a division sign in here. And if I did that, what would cancel out? Yeah, I have the same denominator. The 2's would cancel out. Some people like to think of it as multiply by the reciprocal. That's the same idea. Okay, if you multiplied and flipped that, the 2's would cancel out. And you would have that. Okay, only problem, we got to fix that square root. Okay, so how do I fix the square root there? Times by square root 3 over square root 3. And what will that give me? Square root of 3 over 3. Okay, remember, square root 3 times square root 3, you can think of that as square root 9, or 3. Okay, now what are we going to do with all 3 of these to get the next 3? Flip them. Okay. That one's easy, that's 2. This is 2 over square root 3, which would become what?
2 times the square root of 3 over 3.
2 multiplied by the square root of 3 over 3. Now, for cotangent, you've got 2 things you can flip. You've got 1 over the square root of 3, or square root 3 over 3. They're equal to each other. They're the same thing.
Flip the first one.
I would flip the first one. How come?
And then you don't have to do any more work.
Yeah,
Square root's on top.
yeah, if you flip the first one, the square root goes to the top, and you're done. If you flip the second one, that's okay. It's going to put the square root in the bottom, and then you've got to fix it, and you're going to end up with this anyway. Okay? So try to make life as easy as possible.
What do the square roots inside when you flip it? So like square root of 3.
Like when you multiply square root of 3 times square root of 3? Because the square root of 3 times the square root of 3 is the square root of 9.
Okay.
Or just 3. Okay. Any other questions on this one?
No.
All right. Okay. Now this one says find the 6 trig functions of pi over 3. Okay. What might you want to do first here? Yeah. If you don't know what pi over 3 is, it is 60. You could change to degrees. Okay. Looks like some people already know it's 60. So now, does anybody remember? If not, we're going to have to make a sketch. But what's our coordinate for 60?
1/2 or square root of 3.
Yep. 1/2 square root 3 over 2. This is where the triangle is standing up taller. The base is the short side. The height is the long side. Go back and look at the diagram. So since my x and y values are the same as the last problem, except switched, I'm going to see all these answers, except they're all going to switch places. Okay? So now my sine is root 3 over 2. Cosine is 1/2. And when I divide these, what's my tangent?
Square root of 3.
The 2's cancel out, and we get just square root 3. If you go back and look at the previous problem, you're going to see all those answers in different spots. Right? Cosine, that's a quick one to flip. We just get 2. This one, what do we get when we flip it and fix it? Final answer. Yeah. 2 square roots of 3 over 3. And how about when we flip and fix that one? Square root of 3 over 3. Yep. Okay, so any questions on that? Yeah.
About how you have like the pi over 3, that's equal to 60 degrees, right?
Yeah, every one of these, it's the sine of 60, cosine of 60, and so on.
And the 3 pi divided by 2, that's 270, right?
3 pi over 2 is 270. Yep. We didn't do that one today, but we did that yesterday.
The square root of 3 over 1, can you just say square root of 3?
Yeah, I just put the one there in case people had trouble flipping it. But yep, if I was going to write the final answer, I would just put that. Square root of 3. All right, so that's everything we can do in the first quadrant. 45, 30, and 60. Okay, we're going to get into the other quadrants, but we're not going to do all the trig functions. We could, we just have to flip them. Okay, but I think we have enough practice flipping. Let's sketch 135. Okay, first thing we got to figure out is if this coordinate has something to do with the 30, 60, 90,
49.
or if it's the 45, 45, 90. Okay. Here's 90. Here's 180. Where's 135? It's exactly in the middle. Okay. If you took 90 and 180 and averaged them, 135 is exactly in the middle. Right? So this is 135. So what kind of triangle is this? The 45, 45 or 30, 60?
The isosceles triangle.
Yeah, it's an isosceles, so it's, yep, it's 45, 45, 90. The only difference is this triangle has been flipped into quadrant 2. Okay, so what are the lengths of each one of these sides? Just start with that.
So we double what they were.
Right, the x is now going to be negative. All right, so what are both of these lengths? They're both the same number. What are they? Yep, they're both square root of 2 over 2. It's still a 45, 45, 90. But now you've got to remember when you write your coordinate, the x is negative. Okay, you flipped it into quadrant 2. That's all that happens when you do unit circle trig in the other quadrants. It's the same coordinates, except sometimes you need a negative. That's the only difference. Okay, which one gets the negative here, x or y?
X.
The x. How about the y value? That's up, so it stays the same. Cameron?
I was going to say, could you just add or in this case, you could take away 19, find out if it's 45 or 60.
Yeah, you can look at it like ask yourself, does 30 go into that number? No. So this is not the 30, 60, 90. 45 goes into that number 3 times. So that is a 45, 45, 90. Plus it ends in a 5. Okay? If a number ends in a 5, it's not a multiple of 30. That's not possible. All right, so what's my sign here? And this time we got to be careful because if we mix them up, we're going to get this one wrong. Square root of 2 over 2. My cosine? Negative square root of 2 over 2. And my tangent. I'm dividing two things that are the same, except one of them is negative. Negative 1. Yep. Hey, any questions on that one? So that's a 45-degree angle in quadrant 2. All right. So this one, I'm going to show you a trick to figuring out how to convert it in your head. Okay, pretend the 7's not there. What's pi over 6? That's 30. What's 30 times 7? 210. Okay, so all I did was say, what's pi over 6? I said, okay, that's 30, but this is times 7. So what's 30 times 7? 210, right? That's going to be a multiple of the 30, 60, 90. This time I think it's helpful to make a sketch. Figure out where's your short side, where's your long side. That's 180. That's 270. Where's 210? Closer to 180, closer to 270. Closer to 180. Okay, so I'm going to make my triangle. Okay, where's my long side here? On the x-axis. Okay, this is the long side. Okay, and the long side is always what number? Root 3 over 2. We'll worry about negatives when we write the coordinate. And how about the short side? 1/2. Okay, so I know my x, I know my y. What about negatives? Which one gets a negative? Both of them. I'm going left and down. So left, root 3 over 2. And then down 1/2. Okay, so my sine. Okay, sine is going to be what? Negative a half. Cosine? Good. And my tangent, I've got a negative divided by a negative. Those cancel. The 2's cancel. And I just have 1 divided by square root 3.
So we always carry the negative over for both.
Oh yeah, yep. Keep the negative with the number.
Okay.
Here I didn't because the negative divided by negative is positive.
Square root of 3 over 3.
Yep, square root 3 over 3. Okay, so when you do unit circle trig, you start seeing all the same answers over and over. You see root 3 over 2's, root 3 over 3's, half, root 2 over 2, and everything I just said with a negative. Okay, but those are the only kinds of answers that keep popping up. All right, so if we have an angle that's not a multiple of 30 or 45, we got to use the calculator. All right, so I'm going to show you how you type it in on a calculator. This part's pretty straightforward. All right. First thing, what should I check on my calculator for this, because of this specific problem? I should make sure what? Think about angles. How do we measure angles? What's one way? Yep. Radians. What's another way? Degrees. We have to tell the calculator what way we're measuring angles. Okay, if we don't, we're going to get it wrong. So how are angles being measured in this problem?
Degrees.
Degrees. Okay, because it's got the circle. If I take away the circle, just by doing that, now I just made this whole problem radians. I'd have to erase all my circles. Okay, so be very careful if you see a circle or you don't see a circle. All right, so I'm in radians. I need to change my mode to degrees.
How did you do that?
How did you?
Yeah, what's that one?
Yep, just press mode. And then you can choose radians or degrees.
We want degrees.
We want degrees. Yeah.
How do you do that on a scientific method?
Usually there's a button at the top that says DRG. You can press that one. Got it? Okay. On my calculator, all I do is press sine 42, close my parenthesis, hit enter. That's it. Okay, so the sine of 42 is 0.669.
And we do the same with the cos.
Yep, so cosine is the same thing. Cosine 42 is 0.743. Yeah, I would just, oh, I said round to 2. Let's just make it 3, since I already did 3. Okay, and tangent 42, 0.900.
Then when we do the other ones, would they just be all under one?
Yeah, now we just take each one of these and flip it. Now, I'm not going to take 0.669 and flip it. I'm not going to do this, okay, because that's rounded. What I'm going to do is just type the original problem back in. 1 divided by sine 42. That's the only way to do the secant, the cosecant, and the cotangent. I just flipped it. Okay, so 1.494.
On the calculator that I have, it says sin to the negative first. Is that like the same thing?
Nope, that's something different. We'll talk about that next week. Yeah, that's important, but not for today. Okay, 1 over cosine 42. That's 1.346. Okay, and last one, 1 over tangent 42. Okay, 1.111. It's anytime you have an angle that's not a multiple of 30 or 45, this is how we're going to do it. Okay, unit circle trig is only used for multiples of 30 and 45. Okay, questions on using the calculator? All right. I'm not going to go through this, but what would I have to be very careful of before I start this problem?
Change it back to radians.
Change it back to radians. If you leave your calculator in degrees and start doing it, you're wrong. Okay? There's no circle here. Change it back to radians and do the same thing. Okay, so we'll skip over that one. All right, so that flipping that we had to do, okay, we flipped sine to get cosecant, we flipped cosine to get secant. There's a name for that. Those are called reciprocal identities. Okay, and here they are. We've already got, I think, parts of them written down. But it shows us if you take the sine and you flip it, you get the cosecant. If you flip the cosine, you get the secant. If you flip the tangent, you get the cotangent. Notice what happens if you take the sine and flip it, you get cosecant. And if you take the cosecant and flip it, what do you get back? You get the sine back. Okay? So you can just keep flipping it, and it goes back and forth. If you flip the secant, you go back to cosine. If you flip the cotangent, you go back to tangent. Okay? These are all called reciprocal identities. And it's called an identity because it's not just true for if your angle is 12 degrees. It's true if your angle is anything. It doesn't matter if your angle is 12, negative 76. Okay, it's always true. Okay. And below these identities, leave a little bit of space. I'd say however much space you left to write these, leave that much more space below it. Because I'm going to give you some other identities. We're not going to use them all today. But it's good to have all of these formulas that I'm about to give you in one spot. So when we do use them, you're not flipping through multiple pages to find them. Okay, so I'm going to show you one other thing first, but then the other formulas, I want you to keep them all in the same spot. Okay? So leave some space. Okay. Questions on those identities? You've been using them for a couple days now. I just didn't tell you this is what they were called. Still copying? Okay, a few special properties that are unique to sine and cosine. Okay, I don't think we've looked at a graph of them in this class yet. Later on, we'll spend some time looking at the graph. Okay, but the graph of sine and cosine looks like that. It's a wave. And it goes left and right forever. Okay, so the domain for sine and cosine is negative infinity to infinity. How about tangent, secant, cosecant? Those are different. Okay, we're not going to talk about those today. And how high does it look like this is going? 1, and how low? And that, yeah, it's negative 1 to 1. Okay, the other trig functions are totally different, so we're not going to talk about those today. Okay, and the last idea is, if you look at this function, okay, what's really happening is it's repeating itself. We'll get a copy of it here. If you just look at this section, okay, that section that I just tried to highlight summarizes the entire graph. Just copy and paste what I just drew over and over, left and right, and you get the graph of sine. After you go through this section, the graph is just going to repeat itself and do the same thing again. How many degrees do you think you have to go through before you get all the way back to where you started and it's going to repeat itself? 360. All right. So, or 2 pi, same thing.
What did you type in the calculator?
I typed in sine of x and then I did zoom 7. We haven't talked about zoom 7 yet, but I did zoom 7. So since trig functions repeat themselves every 2 pi, or every 360 degrees, watch what I can do. I can take the sine of 10. Okay, that's my answer. What do you get if you add 360 to 10? I'm going to take the sine of 370. Same thing. Okay. I can add 360 again. What do you think I'm going to get?
Same answer.
Same thing again. I could take and add 360 again and again and again. I could add it n times. I could add it as many times as I want. And the same thing is true with cosine. I could take the cosine of 5. I could take the cosine of 365. I could take the cosine of 365 plus 365. I could keep adding 360 degrees n times, as many times as I want. And I keep getting the same answer over and over. Okay, on this graph, that's kind of like looking at this. You have the same height there, same height there, same height there, same height there. Okay, it's just like going over 360 degrees. You get the same height all the time. Okay? And this property is special to sine and cosine. Okay, and it's called the periodic property. And we're going to learn when we study these graphs more that what I just traced in red, that's called a period of the function. So this is called the periodic property. It just means that it repeats itself every 360 degrees. That's all it means. Hey, any question on that? All right, so the last thing I'm going to do is give you that complete list of identities. I just gave you the first 6. I said leave a little space, and I'll show you maybe one problem we can do with them that's very similar to what's on the test. Okay, so these are called identities because they always work. Doesn't matter what your angle is. They always work. Okay. Like this last problem. I did it with 10 degrees and 5. You could have named any angle you wanted, and I could have made it work. Doesn't matter what the angle is. Okay. So the first set of what we have for basic or fundamental identities are the reciprocal. You guys already have all those. Okay, the next ones are tangent and cotangent. And you guys have really already been using this one. Remember we did sine was y. What was cosine? That was x. And what was tangent? Y over x. Okay. Well, you just told me up above, y is which trig function? Sine. And x is which trig function? Cosine. Tangent is really sine over cosine. We've been doing this. When I said pretend you're drawing a line and you're going to do division with sine and cosine to get tangent. Okay, we've been doing that all along. Okay, and then the last one, cotangent, if you flip it, you get cosine over sine. Okay, so that's another way to write cotangent. Take cosine and divide by sine. Okay, the last 3 identities, I'm putting them on the board. I'm not even going to talk about them today. The only reason I'm putting them is because they're good to have in the same spot as the other ones. So while we're writing them, we're going to put them in the same spot. These are not on the test. Okay, these are called the Pythagorean identities. You might be able to guess why they're called that, because Pythagorean theorem has a lot of things squared. Well, this has things in it that are squared.
What's the arrow for?
Nothing
Nothing.
in particular. Yep. And if you're wondering, well, what does that mean when you put a little 2 near the trig function? It's the same as writing this. You can either put the 2 right above the trig function, or you can just put parentheses and put the 2 on the outside. Most people would write it like this because it's shorter. Just means sine squared. Sine squared. Okay, those Pythagorean ones are not on the test. All right. Yeah, I'm not going to worry about that right now. All right, this is our last problem. All right, so sometimes what they're going to do is give us something that looks like this, and there's an easier way to write it. Okay? What I want to do is go back and look at my formulas. I want to look at what cosecant is, and then I'm going to look at what tangent is, and hopefully maybe something is going to simplify. Okay, what's another way to write cosecant? just using one of these formulas. Yeah, cosecant is the same as 1 over sine. Yep.
Just scroll down to
So I'm going to replace cosecant with 1 over sine. Why? Because I can. It's an identity. Okay. What about tangent? What's another way we can write tangent? And we're going to stick with writing it with sines and cosines. I think you'll see why in a second. Sine over cosine. Now, whenever we have the same thing in the top and bottom of a fraction, what happens?
Cancel out.
Yeah, so something just disappeared. What am I left with in the top? 1 over cosine. And we could leave it like that. Or do we have a simpler way of writing 1 over cosine? Secant. Yeah, so what ended up happening here is we just simplified cosecant times tangent. Okay, that's called a trig identity. Okay, there'll be one problem just like that on the test. Usually the trick is if you change everything to sines and cosines, something cancels out. And all you need is these basic identities right there. Okay? So if you got stuck on this trig identity, don't worry. We'll practice some more before the test tomorrow. Okay. Questions? Okay, you know what? I'm going to have you do example 8 instead of this. Okay, so on page 335, try 13 to 16, 21 to 24, 29 to 32, and then 37, 39, 45, 46, 55, and 56, and try simplifying this one trig identity. Okay, my hint is look back at your formulas and change everything to sine and cosine, and something will cancel out, just like the last problem. So we'll go over that right at the beginning of class. If you are staying after school today, please come see me at the end of class, and we'll talk about that. Otherwise, make sure all tests are made up by tomorrow. Okay?